Determinant method of solving simultaneous equation. In today's lesson, we are looking at determinant method of solving simultaneous equation, and we are looking at three equations in three unknown, that is third order determinant, using this example. We have 3x plus y minus 2z is equal to minus 6. X plus y plus z is equal to 7. Then 4x minus 3y minus z is equal to minus 29. How do we proceed? First, make the coefficient of the x, y, and z a matrix of their own, such as you have something like this. Coefficient of x here is 3. Coefficient of y is 1. Coefficient of z is minus 2. And coefficient of x here is 1. Coefficient of y here is 1. Coefficient of z is 1. Coefficient of x here is 4. Coefficient of x here, of y here is minus 3. Coefficient of z is minus 1. Then you have the value, we have the unknown we are looking for. X, y, z will be equal to the answer minus 6, 7, minus 29. Then find the determinant of the matrix itself. That's determinant of the matrix itself, ordinary determinant of the matrix. Or let's say the matrix is P. So let's find the determinant of the matrix. If you do the determinant of this matrix correctly, it's supposed to give you 25. We've treated determinants in our previous classes, so if you don't understand how I got this 25, you can check my previous lesson on determinants. Now, to find determinant of y, you have det y or det x first. Determinant of x. Replace the coefficient of x now with this answer. Replace the coefficient of this x with this, so that you have something of this nature. So the whole of this will replace this. That will be minus 6, 7, minus 29. So you have 1, then you retain this one and this one. 1, minus 3. Then you have minus 2, 1, minus 1. So this is our determinant of x. Then if you do the determinant of x correctly, from your knowledge of determinants, either using Sarus or Cramer's rule, and we will have that x is equal to minus 50. Now, how do we get that y? Determinant of y. Then I will retain this one, replace the coefficient of y now by the answer. The coefficient of y, which are these ones, by this answer. So I will have 3, 1, 4. And I will replace this one with this. That's minus 6, 7, minus 29. I will retain this one also. Minus 2, 1, minus 1. And I'll get my determinant of y. Should be equal to, if you do your determinant correctly here, you will have 150. Then to get that z, I will do the same thing. You have determinant of z. I will retain this and this now. Replace the coefficient of z now with this answer. So I will have 3, 1, 4, 1, 1, minus 3. Then the coefficient of this now, I will replace them with this. That will be minus 6, 7, minus 29. Then my det z, if done correctly, will give me 75. Now, since I've gotten my determinant of the matrix itself, determinant of x, determinant of y, determinant of s, z, and to get my x now, x will now be equal to determinant of x over determinant. That will be my x, because determinant of x is minus 50. Then over the determinant, which is 25. If I reduce, x will be equal to minus 2. Then to get my y now, I'll do determinant of y over the determinants of the matrix. Then my y will be equal to 150, which is determinant of y over determinant over 25. Then y will be equal to 6. To get my z, you have z will be equal to determinant of z over the determinant of the matrix. So my z will be equal to 75 over 25. So my z will now be equal to 3. So this is how to apply matrix determinant method of solving simultaneous equation. So therefore now, and I say therefore our x is equal to minus 2, y is equal to 6, then z is equal to 3. So this is an example of how to use determinant method of solving simultaneous equation.